Let's now take a look at the Data Transform Editor dialog in ProRaster. I'm using ProRaster Premium. So I have some terrain data displayed, just looking at color at the time being, using a linear transform, and I've got a 0.5% quantile clip, which clips off half a percentile of the data at the top and the bottom. So that's a standard data transform, and that's what it looks like. So let's go into the Data Transform Editor. I have no data transforms stored at the moment, so we have an empty dialog. So let's add a new data transform. Like all resources in ProRaster, you must give it a name. So I'm going to call this linear clip. And that name must be unique. If you get a tick over here, that means you've got a unique name. And you can press that tick to have it accepted. As you add in new transforms, they all appear in this list. You can then delete them using this button. You can clone the selected data transform using this button. So now we have 2 linear clips. And using this button here, you can delete all of your data transform definitions. That's the nuclear option. If you accidentally press that button, don't press OK. Once you hit OK, any changes that you make in this editor will be committed. If you hit cancel, all the changes that you've made in this editor will be discarded. So I've created a data transform, I've given it a name. Now I need to select a data transform type. So I'm going to use linear. And so what we now get is some property pages which tell us about this transform, allow us to edit it. And over here we have a preview of some raster. Now, because I was working with this raster in the dialog, it's chosen that raster as the default. So in this preview, you can zoom with the mouse wheel, and you can pan by left clicking and holding and dragging. You can close that if you wish, or you can reopen it with that collapse button. So just a few other things on this preview. These 3 pages, raster, statistics and histogram, are all about the preview and not so much about the data transform. So here you can select the raster source that you want to render in the preview, and by default it's selected the one that I was working on in my algorithm. And then you can select the field and the band that you want to display. So you've got your default, which is field 0, but then you can go into manual settings and select both the field, the events and the bands, and hit OK if you want to see something specific. Now there's some useful things in this data transform editor. We have a statistics page. So this is giving us the summary statistics of the raster that we're displaying in the preview. So you've got your sample count, number of valid samples, number of invalid samples, and additional count information. Here's your summary statistics, minimum, maximum, mean, your standard deviation. Here's your distribution statistics, so your upper quartile, your lower quartile, your interquartile range, your mode, your medium, and then you've got these spatial statistics as well, which are the cell-to-cell variation values. So there's some useful information there. And then finally we've got the histogram. So we're getting a spreadsheet of the histogram for this raster. So here are the bins, 0 through to 1023. The bottom of the bin, the minimum value. Let me get this, make this clear. So the bins have a certain width, so that will be their bottom and their top. But inside each bin, we have data values, and they may not stretch from bottom to top. So they only stretch from min to max, and that gets recorded in each bin. So that might be somewhat smaller than the actual bin values. Then over here we've got count. This is the number of samples that's in that bin, and then you've got your cumulative count, which goes from 0 up to 1, which represents the percentage of samples accumulated up to and including that bin. So instead of viewing it as a spreadsheet, you can also view it as a graph. So here's our histogram distribution, and here's our cumulative count. And if you like, you can stretch that graph, so we can use some logarithmic stretching in the vertical axis, low or high, and in some cases that can show you some more of the detail in the distribution histogram. So a couple of useful things there. Now let's take a look at the transform. So I've chosen a linear transform, and that's reflected here. Now with a linear transform, and with most transforms, the main thing that you want to do is determine the bottom and top clipping limits. And that's this bandpass. And those clipping limits can either not be specified, in which case it'll use statistics, or you can specify it using data values, or you can specify it using percentages of the data range, or you can specify it using percentiles, which are quantiles acquired from the histogram. So if I put in percentiles, I go from 0 to 1 by default, so these are percentages so this is 0%, this is 100%. We're using decimal numbers. So I put in, say, 0.1 at the bottom, and the top I'll clip out at, say, 0.95. And I get a preview of the distribution of that color over that raster. Now I should point out that the color table that you're using in your algorithm is not used in this preview. In the preview, we just use a pseudo-color color table, and other things that you're doing in your algorithm aren't mirrored in this. This is just a default algorithm, and it's only designed to show you the result of this transformation. So let's go back to 0 and 1. So we have effectively no clipping now. In fact, we can put on none. And now we have this option, outlier clip bottom and top. So in the histogram, we've identified outliers. So if you clip off, say, the bottom 2 bins and the top 2 bins of the histogram, then you will eliminate most of the lower and upper outliers, potentially. And you can see that the transform changed. So this is a handy way of clipping out. Let's just make it 1. You can clip out the most extreme data without knowing what that extreme data is. You just say, I want to knock off the bottom and top bin of the histogram. Alternatively, let's go back to no clipping there. Of course, we can put in data values. So if I want to clip from 0 to 2,500 meters, this is terrain data, of course, and we'll see that. Now, you have a couple of options down here. So firstly, you can reverse the transform in some cases. So click that, and you can see that it reverses. Another way of kind of reversing the transform is to reverse the color table, and you can do that in your algorithm. Secondly, you have this full color table option. I click that here, it won't make any difference. But if you have something like a range, so let's say you have 8 ranges, well then usually you'll just display 8 colors. But you do have the option to interpolate across those ranges, and so use all of the colors in your color table. So in which case you can click this on to use the full color table, and then you're not limited to, say, the number of ranges. And finally, we have this scope setting. So you can either transform over the bandpass range, which is established here, or you can transform over the full statistical range. It's a bit hard to explain without a diagram, but so that allows you to, so if you to transform over the statistical range, you could put in clipping, but still have a full min to max transformation, but then use the clipping to clip out data below and above some certain range without modifying the transformation. So let's have a look in here at all these different things. So we have all of our different kinds of transformation. Our pass options, our rotate options. So let's see what happens when we select them. So pass scaled, all of this goes away. Pass index, all of this goes away. Pass value, all of this goes away. Rotate index, well, okay, we need to say how many colors we've got. Color bits linear, here again we need to specify how many colors we have. Then we have our linear, which we've just seen. Here in logarithmic we've got some additional controls. Here we can control both the base of the logarithm and the transition value. So if I make this 100 for the transition value, this is and I won't explain what that is. We can also change here, which we can't change in the algorithm settings page. You can change the log base. So I could make that a log base 2, for example, instead of log base 10. So that's our logarithmic. In sigmoid, here we have the k value between -1 and 1. So remember that this has both lightening and darkening. So darkening is negative. So if we put in negative 0.5, we get some darkening. And if we put in positive 0.5, then we get some lightening. Or it might be the other way around. I'll let you discover that. And then we have our equal area and the stable equal area. And again, here we have our percentage, where we can scale between no equal area at all. So there we're getting a linear transformation, and 100%, remembering that in this dialog everything is decimal, so 1 for 100%. And then we have full stretch, and if we just want part stretch, we put in, say, 0.5. So that's our equal area. Then we have all the ranges. So ranges spread about the mean, about the median, about the mode, deviations about the mean, and Jenks natural breaks. Okay, so I have a Jenks natural breaks algorithm with 8 ranges, and there's our result. So moving on, you notice that none of the other range options are in here. They've been consumed by these table options, so let's look at those now. So if you click any of one of these, and I'll start with index over range, you get a new property page, which is your table property page. This has a spreadsheet which you can edit. You set the number of rows in the spreadsheet from this member variable here, then hit set. If you want to reset the values in the spreadsheet to default values, hit reset. So let's go back down to 8 rows, hit reset. Note that you can also undo the edits that you make. So if you screw up, you can fix it. So we have an index over range. So we need to specify what the range is. So I might do that in data values. So I'm going to go from 1,000 to 4,000 meters. We're looking at a terrain data set. And then over here we have 8 colors spread over the color table. So let's just go OK. And zoom in. So you can see here that our first range, blue, is up to about 1,000 meters. And then it goes on from there. If we put on clipping, you can see that we're clipping it at 1,000 meters, and then above 4,000 meters, which was the range that I specified. Next is index for value. This is one that you might use. So in this case, we have to type in the data values, in the same as the raster cell values, into here, and over here we have our index, which is our color index between 0 and 1, which maps into our color table, however many colors it has. So let's put in some values here. So 400, 800, 1600, 3200, 6400. And you'll see that it maps right from 0 up to 1. Now, if you put in 1, that's actually the first color past the end of the color table. So 6400 represents the top of our transform. And if we have a look at it in here, we'll turn this clipping off. So our first color went from 0 to 100, then up to 200, then it went to 400, then 800, where are we about there? Then 1600 around here, then 3200, then at 6400 we reached the top of the color table, so we're seeing our red right up at 6400. Again, we put on our clipping. We'll clip out that red because it's above 6400, and we'll clip out below 0, so here's perhaps some areas below 0 there. The next one is index for percentage. So now instead of data values, we've just got percentages of the data range. And again, you can establish what that data range is from here. So if I put in again data values from 1000 to say 5000, and we have our 8 colors, so let's go OK. And looking in here, we'll see the same kind of thing. We clip above and below, we'll be clipping now at 5,000 meters, which is about right. And we're clipping at 1,000 meters, which is about right. Next one is index for percentile. So this is exactly the same, except these are percentiles now, computed from quantiles on the histogram rather than percentages. So you can see that we're getting more of an histogram equalized transform. The last four are match value range, match continuous value range, and match value string. These do exactly the same thing as what you can achieve through a legend color table. The only difference being that a legend color table, in addition to the values and ranges and strings, it also specifies the color. And in most scenarios, that's probably what I would use to achieve this. So I probably wouldn't use these options. So here we have a individual value which you would match to a color. You wouldn't use it on a terrain grid like this. You'd use it on something like a classified raster. Then match value range, where we have a minimum and maximum, which would all match to an individual color. Match continuous value range, very, very similar. And then finally match string, which again you'd use on something like a classified raster. And so these ones, you're not going to be interpolating colors, you're just going to pick out a color. You're probably going to want a specific color from a specific color table, which has an exact matching number of colors that you have in your table. And because of that, I would use a legend, color legend, rather than use these options in here. So that's the data transform editor in ProRaster.